In general, in order to solve complicated equations involving logarithms, we're going to need some more powerful tools than we have access to right now. However, we can solve very basic equations involving logarithms just by rewriting them in exponential form. So here's an example of a very basic equation involving a logarithm. It just has some logarithm equals something. And to solve that, as I said, we just rewrite it in exponential form. So the base is 4, the base stays 4, and the argument and the exponent trade places. So the exponent becomes -2, and the right-hand side becomes x. We've actually already solved that equation, haven't we? We have x equals some number. We just need to work out what 4 to the -2 really is. So x equals 4 to the -2 is 1 over 4 squared, or 1/16. You could also do that on your calculator if you'd like. Our solution is that x equals 1/16. Now, we might also need to take a root or use some sort of trial and error, as in this second example. So here my variable is actually in the base of my logarithm, but my base stays the same. The exponent and the argument switch places. So x to the 4th equals 81. Okay. Well, now I want to undo a 4th power. I know how to do that. That's a 4th root. Or if I'm thinking of this as a power function, 81 to the 1/4 power. Now you might be thinking, wait a minute, I'm taking an even root here. Don't I need a plus or minus? Why don't I need a plus or minus here? Well, my variable x comes to me in my equation as the base of a logarithm, which means that it must be a positive number. Right? Bases of logarithms are only allowed to be positive numbers that are not 1. So that means that I only need to look at the positive root. Right? This can only be a positive root, which means the only solution is, well, the 4th root of 81. You can do that on your calculator if you like. It's x equals 3. We can also use this strategy of rewriting in exponential form when we want to evaluate a logarithm. That is, when we want to work out what an actual log is. So if we want to work out what is the log base 4 of 32, well, we can write it as the log base 4 of 32 equals x, and then rewrite in exponential form, 4 to the x equals 32. The exponent and the argument trading places. Now, we might see if we can do that by trial and error, right? 4 to the 2nd is 16. 4 to the 3rd is 64. Okay, our answer has to be somewhere between 2 and 3. But the other strategy we have for solving an equation like this is to rewrite everything in terms of the same base. And we know that 4 is 2 squared. Is 32 a power of 2? Yeah, a little trial and error tells us that 32 is 2 to the 5th. So this equation says that 2 squared to the x is 2 to the 5th. Power of a power will multiply these exponents, and then the exponents need to be the same. So we get 2x equals 5. X is 5/2. We've just evaluated this log. The log base 4 of 32 is 5/2. And we can confirm that by noticing that 4 to the 5/2 really does give us 32. Not too bad. So as long as our log is a nice number, we can also use this technique to evaluate a log. And more generally, we can use this technique to solve any simple equation that involves a log.